Okay, so today we're still talking about graphs of exponential functions, but we're taking it from the other direction. Instead of giving a function and making the graph, we're going to look at a graph and we're going to write a function to describe it. Actually, outside of the math classroom, this is probably a more effective use of some of our information. Like if you have a model, you have a data set, you think it's exponential, you try to fit an exponential model to it. And that's some statistics and regression, but a lot of, if you're studying science, you'll end up with things like this. You have to model it. So for this, it does tell us we're going to model this in the form y equals a of x, and this is the first problem here on our worksheet. So what we'll see here is this is the only form we've really been graphing, and we'll look at what happens if there's a multiple here. But what you'll see, if we're going to model in the form y equals a to the x power, we still know that x and y are variables, right? Because it's an equation, so we have to have an x and a y to draw an equation. So the thing we need to solve, we have one unknown, and that's going to be a. We have to figure out what is a. Okay, so usually if you only have one unknown, you're going to be able to solve it with one equation. If you have two unknowns, you tend to need two equations, so on. So with this one, what we'll do is we know that on this curve, we see we have 2 points. We have the point 0, 1, and we have the point 2, 9. Okay. You could try either point in here and see what happens. Now, if you try 0, 1, so we're going to put a 0 in for the x and a 1 in for the y, it tells us that 1 equals a to the 0. That doesn't really tell us what a has to be, does it? Because anything to the 0 is 1. So it's nice to know, but it doesn't really help. Let's try the other point, which is 2, 9. For this one, we're going to replace the y with 9, and then a squared. Now, I think we could get somewhere with that, right? If 9 equals a squared, to solve this, we square root both sides, don't we? I know you're all out there thinking, well, we square root both sides, that's going to give us a plus or minus 3, because I know that any time I square root, I get a plus or minus. But here, with an exponential function, we don't have negative bases. Bases are always positive. So we automatically choose a. So a is 3. So that means the model would be y equals 3 to the x power. So that's what we're doing. You're just taking the format, right? Taking your point or points and plugging them in, solving it. We solve for a. We rewrite the format still using x and y, but we replace the base with whatever we solved for. So go ahead and try. Okay, so for our next example here, hopefully you tried it. We have just this point, -1, 1/5. Now do note, this is also exponential growth like the last one, correct? So since it has this shape and it's exponential growth, what do we know about the base and its value? Anything? No? Oh. Well, it's always positive, but it's going to be bigger than 1, right? It's going to be bigger than 1, right? Because that means it's going to be exponential growth. If you get one that looks like this, right, where it's exponential decay, means your base is going to be between 0 and 1. All right, so here I think it did say, you might see model in the form f of x equals a to the x. Just remember that f of x, we could just replace it with y in this case. Okay, so now we saw last time plugging in 1, 0, or 0, 1 didn't really do much for us. So let's go ahead and try the other point. So 1/5 equals a to the -1 power. Now, but you know, last time was nice, we just square rooted, but here we have to get rid of a -1 power. There's a couple ways to do that. You could write it as 1 over a, and then cross multiply, right, and then solve it that way. What I tend to do is I'm going to raise both sides to a power that's going to get us a first power on a. So what I like to think of it, the way I like to do it, is I'm going to take both sides to the -1 power. Because we know here we multiply the exponents, correct? So that'll just give us a. And then what is 1/5 to the -1 power? It's just 5. So we get 5. So then our model would be f of x equals 5 to the x. Okay. All right, very good. Now the next, there's a couple practice ones there that you want to try. This was one of them. Now, I just wanted to show you one with exponential decay, just to kind of get you exposed to it. Going to be the same model. Right? Still going to plug in the point. So 1/16 equals a squared. Now, at this point, you're probably going to square root both sides, right? Last time we used a little negative exponent trick, but here you just want to square root both sides. We said that the negative value from the square root we're not going to get because it doesn't mean anything with exponentials. So what's the square root of 1/16? 1/4, right? Square root at the top, square root at the bottom. Call it a day. So 1/4 equals a. So we get y equals 1/4 to the x. And we expected that because we see that we have exponential decay here. Right? If I had exponential growth and I got 1/4 as a base, I'd be concerned, right? Likewise, if I had growth and I got 1/2, I'd be like, hey, something's off a little bit. Okay, so here on the back of the paper here, we have another graph, very similar problem. We see we have the ordered pair 212. We see its exponential growth. This time, though, the other two, the y-intercepts were all at 1. This time, the y-intercept is at 3. So something different. Let's see how that works. Now, what also is different is that the model here is y equals c times a to the x. Or I think actually on your worksheet it's f of x equals c times a to the x. But again, we're just going to make that be y. So, but what we notice is when we write our model, x and y will still be variables. But there's two unknowns now. There's c and there's a. So you're getting two unknowns, you need two equations, or in this case, you need two ordered pairs. That's what we're looking at here. So for this one, let's just start like we did before. Let's take the point 212, and we'll go ahead and put 12 in for y, and we'll put 2 in for x. So we'll get 12 equals c times a squared. That's a delightful function. Now, I can't solve for a and I can't solve for c because there's two variables, right? So we need more information. But we have that. We're going to come back to it. So here, let's look at that other point, at this point 0, 3, the y-intercept. If we model that the same way, we get 3 equals c times a to the 0. Now, what's a to the 0? 1. So then what's the c times 1 is just c, correct? So here we get that c is equal to 3. We know one of our values. Right? So then what we can do is over here, this is c for the whole function. So we could take this and we can plug it back in here. So 12 equals 3 times a squared. 4 equals a squared. We don't use the negative value, so we just get that a equals 2. So then our model will be y equals 3 times 2 to the x. Now what you're going to find is if you have this form, which is pretty common, notice that c was 3, just like the y-intercept. That'll happen every time because of this function right here, right? When you're putting that, that's going to happen every time. Now, I'm sure none of you are considering doing this, and I'm glad you're not, but we know that this is a exponent, correct? So we have to do 2 to the power before we could do any multiplication of the 2 and 3. So if I wanted to, say, plug in 4 into this function, right? If I wanted to evaluate it when x equals 4, I do y equals 3 times 2 to the 4th. I have to do 2 to the 4th first, which gives us 16. Then I multiply by 3 to get 48. Right? It's just order of operations. Exponents come before multiplication. That's what we have there. There's another one of those for you to try. And then also on this paper are some modeling problems just for you to take a look at. I think that on the modeling problems on the worksheet, you have to use a calculator. Like you can't not use a calculator. But just go ahead and try them. I think you'll work. It's basically plugging in numbers and kind of can you read it and identify what each variable is. So try those. Try the other ones on here. And then also for this evening, we had the 4 graphs that we were working on earlier. If you didn't get those done, go ahead and get those done too. So we'll take some time and work on those.